Good morning, everyone. First, I would like to thank for the invitation to be here by Eliana and Sergio. And I would like to say that it's a great responsibility to be the first, right? So I'm gonna try to give some introduction of the work that we are doing. Okay? I live on island, the island, the Florianopolis, so we have water everywhere, in an island, right? I'm a professor from the University Federal of Santa Catarina, and I collaborate here with the program of environmental science here at the University Federal of Pará. Well, when we look at the climate, we have to understand what is all the pieces of this climate environment. So the climate system is composed basically of course, the atmosphere. We have all the radiation that will be redistributed and create all the dynamics of the winds and will interact with clouds and gases. So then we have the oceans, the currents, the ice on the mountains, the snow, and the interaction with the vegetation. And all these processes interact with each other. And we have now the influence of human on the climate change. Okay? We are now exactly 1 week from the last IPCC report. So for 6 years, they had worked in this report that came out just 1 week ago. So some of the results that came out, of course, is that it is extremely likely that human influence has been the dominant cause of the observed warming since mid-20th century. And that is mainly because of the greenhouse gases that have increased. We are now about 400 parts per million here today. And if we look at other components of our climate, the mean temperature had increased since last century, and we have now here an increase of the order of 0.8 degrees Celsius on the average, on the global average. And you can see the northern hemisphere has increased more than the southern hemisphere. And a map of the recent increase up to 2012, you can see some regions have increased more than others on the order of 1 degree, more or less. And some other results for the ocean also had warmed since like last 100 years, and we have here this constant increase of ocean temperature. And the mean sea level has risen as a consequence of the expansion of the water. The warming expands the water, and we have also the melting of the ice. So we have then in millimeters here, some more or less 50 millimeters since like 1992, when we have like most of the satellites that can cover a large area and measure the change in the height. The ice, of course, this is the amount of ice, the percentage of coverage of ice for the month of September. Then it has been decreasing in the past years, and was just trying to see. I was going to show here some of the ice, but it didn't show up. We have the Brazilian panel as well. About 10 days ago, the Brazilian panel came out with some results. And for the temperature, all these regions here have warmed in the last 100 years. For instance, here we have the minimum temperature of about 1 degree Celsius since past 550 years. Temperature in the Amazon has increased about 0.83 degrees Celsius as well. In terms of precipitation, rainfall had increased mainly in the South Brazil, over these regions here. Is Some of the regions here had some decrease of precipitation. I'm from the state of Santa Catarina, and we are having now every year problems with floods, floods and landslides. This happened just a few days ago, 10 days ago exactly. The city of Rio do Sul was completely flooded. We had in the state of Santa Catarina 200,000 people that had to leave their homes. So, one of the problems is that the major cities has their rivers that cross the cities. So when you have like more and more rainfall, of course, we have all these problems over the cities, and people had to leave their homes and have to find a place to go. The IPCC has also the scenarios, right? And these scenarios are based on climate models, very complex climate models. And so, as the greenhouse gases increase in the future years, we use them as a scenarios. We can have some optimistic scenario or a pessimistic scenario. And from the report from last week, they came out like with some scenarios for the end of the century. This would be an optimistic scenario, and that would be a pessimist scenario. In other words, with more and more greenhouse gases, we may have an increase of temperature here of the order of 4, maybe 5 degrees Celsius, if the greenhouse gas increase a lot. Also in terms of sea ice, the ice has been melting in the North Hemisphere, and they expect by 2050, some models show that the ice can melt completely in the Arctic. Those are the scenarios for the temperature. The models had shown that by the end of the century, a pessimist scenario, we can have here an increase of temperature of the order of 4 to 5 degrees here in South America. Other regions become have even more higher temperatures. On the left, we have the optimist scenario, in the right, the pessimist scenario. For the rainfall precipitation, we can have also an optimist scenario and a pessimist scenario. If you look at the South America, we can see that some regions that are dry today can have even more drought on the northeast here of Brazil. And the south, we can have more and more rainfall. And that is where I live here in the state of Santa Catarina. That is the region that we have already seen this increase of precipitation year by year. And the ice, I had shown previously the scenarios of ice. This would be an optimistic scenario and a pessimistic scenario with no ice in the Arctic. Another problem is that the waters from the ocean can have more acid because of the uptake of CO2. So the oceans are supposed to be more acid, and that may have other consequences for the water of the ocean. Well, those are the IPCC scenarios that came out last week. And for the global mean sea level rise, they have also some optimist scenario and some pessimist scenarios. That would be here an increase of 0.8 centimeters increase by the end of the century. So, what is a model? I was supposed to talk also about the model. And I will not go up to the equations that way, but I have to say that the model is not as basically what we do in terms of conservation of momentum, that is the motion, conservation of heat, conservation of mass, and the equation of state that integrates all these equations. I will not go to details, only to show you how a climate model works This is a part of the dynamics of the atmosphere of the oceans. And of course, we have to account for how much radiation comes from the sun, and they will interact with clouds and other gases in the atmosphere. And this is one of the most hard parts of the climate model, that is like how to model the clouds. Why? Because clouds would like scatter the solar radiation, and at the same time you can have a greenhouse effect, because we have the water molecules in the air, so these are the most abundant greenhouse gas. When the radiation reaches the surface, we can interact with different kinds of surface. So if you have forest, you may have like warming of the forest, so we have the emission of the radiation, and that can create like convection and local circulations. And we cannot forget that the forest will have here a role to transport water from deep soil up to the atmosphere. So all these processes have to be included in these climate models. Then you have the rainfall. Rainfall is another problem, because sometimes we don't have enough climate model resolution to resolve some small clouds. So we have to treat them as a statistical like population of cloud droplets. In terms of scale, we have, for instance, a cloud seed that is very, very small. So the droplets will grow, water will condense on these seeds and grows, and then we have a very large, I mean by a few millimeters, that is the size of a rainfall drop. When we look, we are here in Belém, and the Amazon has an important role in the formation of clouds. Why? The forest itself emits its cloud nuclei. Those are the biogenic aerosols that will be the seeds for the clouds, that was found in the recent NBA project here in the Amazon. So if we remove the forest, we are likely to change how the clouds do form in the atmosphere. When we talk about climate model, we must treat the climate as a global, or we are now more interested looking at some particular region. So we have to come up with a regional climate model. In this case, if we look at some region, we must like fit these regional models with some global data. In general, the large climate centers do work with global climate models. And sometimes with regional, if you want to have like more detailed microclimate for some particular region. My group, we are now working, trying to do some kind of downscaling for some regions. I will show some of the results here for climate, regional climate model. We are Belém is right over here, okay? This is a scenario of land cover for the year 2050. The scenarios are based on econometric models, so they came out with some like possible scenarios of vegetation cover. So I did use that land cover to try to come out with some sensitivity study to find out how much rainfall may change if we change the land cover. So the results shows that for 2050, we may have a decrease of precipitation mainly over these regions here, and that is because when the clouds do form in the east part here, as a sea breeze, they start creating what we call instability rainfall, and those systems move all over the Amazon, recycling the water over the Amazon basin. So if we remove forest, these systems cannot move anymore to the west part. And if you remove completely the forest, all these regions here will be affected because of the lack of the movement of these systems that cause rainfall in the forest. What I do have here, we are here in Belém. This is another project that we are working. And this is the rainfall rate, millimeters per hour, and winds. On the right side we have here the coastal here, and here is the place where the wind turns. If you look at this region here, the wind moves from the east, and here it turns entering the river, and that's because of the roughness of the surface is more flat, so the winds become stronger here, and that poses some problems for navigation here. Sometimes you have very strong thunderstorms here, and that creates some problems. And here on the left side I have just the clouds and rainfall. Those are some projects, ongoing projects, that we're working here with colleagues from University Federal of Pará. On the left side I have a satellite image. The Amazon River crosses over here, and here you have the Xingu River. So it goes and moves to the Atlantic. Recently we had a field campaign in this Cachoeira Bay, and what we noticed from the satellite image is that clouds do form like cloud streets. So they are aligned by the easterly winds. In the left side I did model these types of clouds. The Amazon River is over here, and we see here from the upward motions how these cloud streets do form, and in the interface with water and forest we have the places where most of the convection starts, showing that heterogeneous the Amazon is very important for the formation of the convection and rainfall. Here in the state of Rondônia, can you hear me? Yeah. Okay. The Ji-Paraná River crosses the center of the state of Rondônia here. This valley was completely deforested. This is the map of the recent deforestation of that region, and the river crosses over here. On the right side I have a simulation of this valley in terms of temperature. You have the mountains where it rains more. One of the results that came out when I was able to take back all the forest, so to compare the impact of this deforestation. What I found is that this deforestation creates local circulations and produce more stronger storms that cause also problems for the river valley. I live here in Leonardo, in the east part of Brazil. In 2004 we had the first South Atlantic hurricane. This is the hurricane named Catarina, the name of the state, because we had only one hurricane. But anyway, about 12 people died that particular event. This is a satellite image, and it landed over here and destroyed several homes. I did show for our modeling that the sea surface temperature on the coastal here is very important for the amount of precipitation that created all these disturbs damage in the east coast of Santa Catarina. In another area in the East Brazil, this is the state of Bahia. The city of Salvador is located here in this bay. As we can see from the satellite image, the clouds do form by the sea breeze, local circulation. They move from the east to the west, based because of the winds that flows from the east. So we have always sunny beaches over here, but rainfall over here. This is where the forest, the part of the Atlantic forest is located here. They take advantage of this rainfall on the east coast. And here I have a model that shows that this regional model is able to show similar aspects of what we observe in the satellite image. Today, we are concerned about local climate. We have a global picture, but we want to look at focus on some particular region. My group now is working to try to have some type of downscaling. We are using this type of model now that we can have like coarse resolution, some particular region that we have no interest, but we focus with higher resolution some region that we have more interest. So Belém is somewhere over here, and here's the river reaching the ocean. These are results that came out last week from my modeling in terms of downscaling. And we run the model for the 1960 and 1990 and compare with new simulations for this 21st century. Some interesting result is that for 2041 and 2050, in terms of precipitation, the model shows a decrease of rainfall in the east coast and the increase of precipitation in the south. But some regions here in the coast may have even an increase of precipitation. Why is that? It seems that the intertropical convergence zone that is located over here, it is expanding. So, it decreases precipitation in their center, but since it becomes broader, it can have more rainfall in the north coast here. And I have a focus, since my model has a better resolution, I can show here some regions that can have even more precipitation, but in the interior parts we may have lower precipitation. And that keeps going for the end of the century as well. We have a similar pattern with less precipitation in the east, more precipitation in the south and west, here in the Amazon. We can focus more in terms of downscaling, looking close to some regions that will have more interest. In terms of temperature as well, the model shows that these scenarios for much higher temperatures, mainly here in the Amazon. This is the region that the global models show also some increase of precipitation, but some coastal areas may have a lower impact and have like temperatures that make, like for instance here in the east coast near Salvador and the state of Bahia, and the place where I live here in Santa Catarina, it seems that temperature may keeps like more or less what is today. I would like to point one problem that we face in terms of understanding the Amazon. Here is the Cachoeira Bay that is located here, a little bit west of the state of Pará. And we did a field campaign that we took several graduate students, about 50 graduate students, in a field campaign in 2006, where we had like radio sounds, a collection of aerosols, we had a tower, we have like measurements in the water, in the river, trying to find out how the CO2 is like being uptaken or released. And I would like to close my talk with this picture of the people that live there in the Cachoeira Bay. They live right over here in this part here where I had these balloons. And what I see here, they are sitting in our gas that we use for the balloons. Okay? And I think that they are the future of the Amazon. They are live there close to the river, and I feel that we need to take care of these issues as well. Well, to find my final thoughts about what I have done the past few years is that, well, climate is changing fast. Extreme events is now the standard pattern. Coastal areas are the most populated and the most highly vulnerable regions. Invest on improving the understanding of the weather and climate system function. We must invest to improve predictability. And invest on human resources such as graduate programs and undergraduate programs, promote international cooperation, and engage the local population. So I came with this overview, and I would like to thank for your attention. I'm here to have a lot of. Thank you very much.